So you probably heard about WasmEdge during the keynote. So we are our biggest use case today is as a lightweight AI runtime, running different AI models, including large language model and audio, video, and all those on edge device and edge cloud, right? So if you're interested, we have, so those are GitHub links, so if you're interested, take a picture and join us in our GitHub community. So we started, I think 5 years ago, right before the pandemic, and so at the time we wanted to do outside of the browser WebAssembly environment. It has its up and downs. So we did serverless functions and plugins, and we joined CNCF at that time as a container alternative. So we have a community have done a lot of work. However, in the past 2 years, it has been emerging very clearly that WASM possess some of the very interesting characteristics that are needed as an AI runtime, because it provides abstraction layer over heterogeneous hardware like the GPUs and also the runtimes, the drivers, and things like that. So that allows using WASM as an abstraction layer allows developers to write their applications, compile to WASM, and then deploy it on any hardware, any driver, and any runtime. So so you can target a wide variety of different, from Huawei to NVIDIA to Mac. Same binary, just to copy the binary file anywhere that you want to run, and you can run it, right? So WASM become, the value proposition of WASM become that, becomes abstraction layer on top of, all the different hardware and runtime we see, in front of, for those AI devices. And so as of today, one of our bigger projects called the LlamaEdge. The LlamaEdge provides, embedded API servers that's fully OpenAI compatible. So you can run OpenAI embedded in your application and switch the model as needed, switch the data, switch the knowledge base, switch things like that as needed, and without worrying about driver dependencies or the runtime dependencies. Does it need Metal 4 on the newest Mac? Or could it use MIX on the older Mac? Or does it need CUDA 11 or CUDA 12? So you don't have to worry about those questions anymore. Just develop your application and have the WasmEdge LlamaEdge API server embedded in it, and then you are ready to go, right? So, so in this talk, I have about 2 minutes left, and so I want to talk to you a little bit about what happened, in the past year or so, since we had this Lightning update since last year in Hong Kong. So obviously, for all the things I've mentioned, more GPU hardware support. So we supported Huawei in the past year. We have ARM NPU, AMD NPU, in addition to the usual suspect like the NVIDIA CUDA device and things like that. We have more drivers. We have on NVIDIA, we have TensorRT, not just CUDA, but also more high, more advanced runtime. On Mac, we have MLX, and we have heard Metal 4 was just announced yesterday at the WWDC, right? We're going to soon have support for that as well. We have more runtime support. So we used to, the biggest runtime we supported in the past has been llama.cpp, but now we have Onyx, we have Torch, we have OpenVINO, which come from Intel, we have WebGPU, WebBitnet.cpp, which is a llama.cpp variant released by Microsoft. They can run model at 1 bit quantum level, so it's so they can compress the model. If you think about the DeepSeek MOE, it's a huge model at 16-bit precision, but they can compress to 1 bit, right? So more models. We can support a lot more large language models and virtual vision models, embedding models, ASR like Whisper.cpp, TTS. That's all kinds of voice cloning and things like that. That's where you get full-blown voice interactive applications that can be built on the edge using frameworks like this, right? So one of the, if you are in the WASM community, and people talk a lot about the upcoming WASM standard, which is component model, which because this may not be the right audience, I just want to mention briefly that we are one of the leading WASM runtimes that has full support of component models coming up, I think, in the 0.15 release, because that involves a new set of standard and a new set of even a new set of bytecode standard that we have to comply to. And we support a bunch of other, community-driven WASI standards that's been standardized in W3C, including making debugging easier, memory management, and things like that. But the things I really want to do, I know there's a lot of links, is a lot of contributions in WasmEdge come from the LFX mentorship community. So we have a lot of graduate students and even college students working on a lot of our outstanding issues. And as you can see, those are all GitHub issue trackers, and each of those students spend 3 months with us and make contribution to a major feature. So for instance, you can see one of them at the bottom is to support Apple MIX as WASI and backend. So so they re-implemented a lot of those lower level device driver level logic from Metal to MIX, and so one student spent 3 months and accomplished that and made a contribution back to the community, right? So so a project like this really has really depend on the community because there's so many things to support, right? So many hardware and some software and things like that. I just want to give a shout out to all the hard work that the students has been putting to make this project possible. So that's it. Thank you.